Hello everyone. In this video, I'll explain how to solve optimization problems using calculus. In particular, using what we have learned about the derivative and how to find the maximum and minimum points of a function. I think the easiest way to teach optimization problems is by just demonstrating how to solve a few of them. There is not some general steps that we can take, but in general, each of these questions are going to be slightly different. There will be some things that you need to basically describe mathematically. You'll be given all of these are like applied problems. So you'll be given some information and you have to be able to write a function or an expression that describes the situation. Now, being able to describe the situation mathematically, that's the main thing. And by using a function or expression. So let's just go ahead and start with this question here. A rectangle is to be inscribed in the function f(x) equal 9 minus x squared, which is the green curve here. What is the largest area the rectangle can have inside? So if I want to draw a rectangle inside this curve, what is the maximum area and what are the dimensions? Well, in order now to come up with the mathematical expression, since he's asking about the area, so we will find the area. An area of any rectangle is length times width. Now let's find out. So length and width. Okay, we're talking about this and this. The dimensions. Now, if this point here, the coordinate of this point is x, comma 9 minus x squared, right? So this is going to be from here to here is x, and this is 9 minus x squared. So my length is 9 minus x squared. Now what about the width? Since this is x, this is also x because it is symmetrical shape, right? So 2x. So now this is going to be 2x. X plus x is 2x. So I can say area equal 2x multiply 9 minus x squared. Now I could expand 18x minus 2x cubed. Of course, you can put it in a right order, the highest degree first, but you don't need to. Now, I found A. What do I need? I need the maximum area. In order to find the maximum area, we need to find the derivative, okay? So, I'm going to say A equal negative 2x cubed plus 18x. So I'm going to find the derivative, negative 6x squared plus 18, and then try to make it equal to 0 to find the maximum and minimum points, the extreme values. And then when you take a square root of both sides, x will be positive or negative square root of 3. Now, let's find the dimensions. So the dimensions will be L equal 9 minus x squared, W equal 2x. Since we have x equal positive or negative square root of 3, say 9 minus square root of 3. We're going to avoid the negative because dimension cannot be a negative. And here, 2 times square root of 3. And that's going to be equal to, that's squared. That's going to be equal to 9 minus 3 is 6. So, and here it's going to be 2 square root of 3. Now, these are the dimensions. Now, the area, maximum area will be equal to length times width, 6 times 2 square root of 3, which is equal 12 square root of 3 unit squared. That's it. So that's the maximum area of a rectangle can be drawn inside the function 9 minus x squared. Now let's look at this question here. Again, same thing, but this time the curve is basically a semicircle. So we need to find the area, which is length by width. Now, if this is x and a square root of 4 minus x squared. This is x, and this is going to be x, so in total 2x multiplied. Now you don't need the brackets actually. Now you can factor it, so a prime and you can simplify it. Now you need to find a prime equal to 0, the maximum points. So I'm going to make this equal to 0, okay? So now I could have a like denominators by multiplying here by square root of 4 minus x squared, numerator and denominator. That's going to be 2, 4 minus x squared minus 2x squared over square root of 4 minus x squared equal to 0. And when you cross multiply, you are crossing this. So now I'm going to expand. Divide both sides by negative 4, that's going to be 2. X equal positive or negative square root of 2. Now, of course, we're not going to take the negative, okay, because we are calculating dimension. So we are going to say the length 2x, width 4 minus x squared, by taking 2 square root of 2, 4 minus a square root of 2 squared. That's going to be 4 minus 2, which is square root of 2. Now the area will be length times width, so it's going to be 2 square root of 2 multiply square root of 2, which is equal to 2 times 2, which is 4, again unit square. So that's everything on this lesson. Let me know if you have any question, and see you next time. Bye bye.